Welcome to The Explainer. So today we are tackling a massive challenge for pretty much every developer out there. How do you take a powerful general-purpose AI and make it an expert on your private data?
All right, so let's get right into it. Large language models. They're amazing, right? But they kind of live in a public bubble. They're trained on the open internet, which means they have absolutely no idea about your internal company docs, your private code base, or your team's wiki. So how do you bridge that gap?
Well, you've basically got two main options. On one hand, you could fine-tune a model. This means actually retraining its core weights on your data. It's powerful, for sure, but man, it is expensive, it's complex, and the knowledge is static. You have to retrain it all over again for updates. Or you can use a much more flexible technique that's quickly becoming the industry standard, Retrieval Augmented Generation. You'll hear everyone call it RAG. To really wrap our heads around why RAG is such a big deal, let's do what we do best as developers. Let's build a V1. You know, the simplest thing that could possibly work, just to understand the core problem we're trying to solve.
Okay, so the simplest idea is pretty straightforward. A user asks a question, your backend code just does a basic keyword search across all your local files. It finds any text that matches, copies it, and just stuffs it all into the prompt right alongside the original question. Then you send this massive context-filled prompt over to the LLM. Easy enough, right?
Yeah, but here's where it all falls apart. This approach is just so incredibly brittle. A user makes a typo, fails. They use a synonym, fails. They type in name in lowercase, like LAN, when the document has it capitalized. You get nothing back. Honestly, it's no better than just hitting Control F yourself. We can do way, way better. So that brittleness, that is the exact problem that a proper, modern RAG system is designed to solve. And this brings us to the real magic, the fundamental upgrade. We need to move from just matching words to actually understanding meaning. The key to this whole thing is a concept called vector embeddings. The big idea is this. We use a special AI model to take any piece of text, could be a word, a sentence, a whole paragraph, and convert it into a big list of numbers. This array of numbers, this vector, is a mathematical representation of the text's actual meaning. And this is a total game changer for how we think about search. We're not doing simple string matching anymore. With semantic search, we're looking for conceptual closeness. We're not asking, does this text contain these exact characters? We're asking, is the idea in this text similar to the idea in my question? The librarian analogy here is perfect. We're not just looking in the index, we're asking an expert who actually understands the books. Okay, so we've got the core concept. Now let's get practical. How do you actually build this out? Let's walk through the blueprint for a modern, production-grade RAG pipeline.
It really breaks down into 5 main stages. This is the recipe for taking a messy pile of raw documents, think PDFs, Markdown files, you name it, and turning them into a smart, efficient knowledge base that an LLM can actually use.
First up, ingest and chunk. You can't just throw a 50-page PDF into an LLM's context window. It'll just choke on it. So you have to be smart. You chop up your documents into smaller, manageable pieces. And that chunk overlap parameter, that's a pro tip. It makes sure you don't accidentally slice a really important idea right in half at the boundary between two chunks. Next, we embed and store. We take every single one of those chunks we just made and run it through an embedding model. Something like OpenAI's text embedding 3small. It spits out a vector for each chunk. Then you store all these vectors in a specialized database, a vector database. You've probably heard of some of them like ChromaDB, Pinecone, or Milvus. And when we say vector, we're not talking about a simple X and Y coordinate. Each piece of text becomes a single point in a, get this, 1,536 dimensional space. It's kind of mind-bending to think about, but the crucial part is that its exact position, its coordinates in that massive space are determined entirely by its semantic meaning.
So you can't really draw 1,536 dimensions, but check this out. If you use a dimensionality reduction technique called t-SNE to squash it all down into a 2D plot, something incredible happens. all the text chunks about similar topics, like all the visa info or all the employee profiles, they just naturally group together into these distinct clusters. That's the proof. The model is actually understanding the content on its own.
Okay, so building the pipeline is one thing. But what happens when you ask a tough question and the system just fails? This is where the real-world engineering and, debugging comes in. This is where it gets fun.
So we asked our system this very specific, factual question. The information is definitely in the source documents we gave it. But the response we get back is, I don't know. And you know what? That's actually a good thing. The model didn't hallucinate an answer. It was honest. It just means our retrieval step failed to find the right context.
So how do we fix this? Well, the good news is we have a bunch of tuning knobs we can play with. We can go back and change our chunking strategy. We could also just retrieve way more documents. Instead of the top 4, maybe grab the top 30 and hope the answer's in there. Or we can do something really clever. We can bring back our old friend, keyword search, and combine it with our new semantic search. This combined approach is called hybrid search, and for a lot of real-world problems, it's the answer. You really do get the best of both worlds. Semantic search is fantastic for understanding the fuzzy conceptual meaning of a query, but for those super specific proper nouns, product codes, or an exact university name, you just can't beat a good old-fashioned keyword match. By putting in hybrid search, we can basically get scores from both systems and combine them. This lets the system put a huge value on the precise keyword match for foreign trade university, while still understanding the broader context of the question. And that precision, that's exactly what we were missing. And there it is. With hybrid search in place, the system is now able to retrieve the exact document chunk that contains our keyword. It combines that precise hit with the semantic context, and now the LLM has everything it needs to give us a perfect, verifiable answer that we can trace right back to our own data. So that's the whole journey, right? We went from a simple, flawed keyword search to a powerful, debuggable, production-ready system. RAG is really all about giving your AI the specific, private knowledge it needs, exactly when it needs it, to be genuinely useful for what you're trying to build.
Look, the tools to do this, the vector databases, the embedding models, all of it, they're out there, and they're more accessible to developers than ever before. Your company's data, your personal projects, they're all unique. The only question left is, what are you going to build with it?